Pydantic AI agents resolve the question of what capabilities an LLM can invoke by composing toolsets that expose functions as callable tools, each registered through a function toolset and conditionally made available at runtime via the toolset's argument to agent runsync. This code demonstrates 3 patterns of tool registration: passing plain functions into a function toolset constructor, decorating a function with a toolset tool to access RunContext, and using add function on an empty toolset to register a lambda dynamically. The following code sets up 2 toolsets, one collecting weather-related functions and another exposing a datatime helper, then runs the agent twice with each toolset separately while inspecting test model last model request parameters function tools to confirm which tools the model saw. Each run passes its toolset through agent runsync, and the print statements reveal the names of the registered tools without executing any actual model calls.
From datatime import datatime. From Pydantic AI import agent, FunctionToolset, RunContext. From Pydantic AI models, test import test model. Def temperature Celsius city, SDR float. Return 21. Def temperature Fahrenheit city, SDR float. Return 69.8. Weather toolset equals function toolset tools equals temperature Celsius, temperature Fahrenheit. At weather toolset tool. Def conditions text, RunContext city, SDR. If CTX, run step %2 equals 0. Return it's sunny. LC. Return it's raining. Datatime toolset equals function toolset. Datatime toolset add function lambda. Datatime now name equals now. Test model equals test model #1. Agent equals agentist model. Result equals agent. Run sync what tools are available. Toolsets equals weather toolset. Print T. Name for T in test model last model request parameters function tools. Temperature Celsius, temperature Fahrenheit, conditions. Result equals agent. Run sync what tools are available. Toolsets equals datatime toolset. Print T. Name for T in test model last model request parameters function tools. Now.
This code demonstrates 2 ways to add tools to a function toolset: passing functions to the constructor and using the @toolset tool decorator, which gives tools access to RunContext. The weather toolset is built with 2 plain functions in the constructor, then a third tool is added via decorator where CTX. Run step drives conditional logic. The datatime toolset shows a separate pattern where you start empty and use add function to register a lambda with a custom name. The @toolset tool decorator is the key distinction here, since it injects RunContext as the first parameter, letting the tool read run state like step count. This contrasts with @toolset tool plane, which is for tools that don't need context. Passing tools via the constructor or add function works for stateless utilities, but when a tool needs to reason about the current run, you need the decorator and RunContext. The agent runsync calls past different toolsets at runtime, showing how tool availability is scoped to each run rather than baked into the agent. Let's break it down.
From datatime import datatime. From Pydantic AI import agent, FunctionToolset, RunContext.
Imports datatime for date-time handling, and from Pydantic AI imports agent, FunctionToolset, and RunContext for agent construction, tool management, and runtime context access.
Def temperature Celsius city, SDR float. Return 21.
Defines a function that accepts a city name as a string parameter and always returns the float 21, ignoring the input entirely.
Def temperature Fahrenheit city, SDR float. Return 69.8.
Defines a function that accepts a city name and unconditionally returns 69.8 as a float.
Weather toolset equals function toolsetools equals temperature Celsius, temperature Fahrenheit.
Creates a function toolset named Weather Toolset that groups temperature Celsius and temperature Fahrenheit as callable tools.
At Weather Toolset tool. Def conditions text, RunContext city, SDR. If CTX, run step %2 equals 0. Return it's sunny. Else, return it's raining.
Registers a tool function that alternates between returning it's sunny and it's raining based on whether the current run step is even or odd, ignoring the city parameter.
DataTime toolset equals FunctionToolset. DataTime toolset add function lambda. DataTime now name equals now.
Creates a function toolset instance and registers a lambda returning the current DataTime as a tool named now.
Test model equals test model #1. Agent equals agentest model.
Instantiates a test model object and assigns it to test model. Then constructs an agent, passing that test model instance as its argument.
Result equals agent. Run sync what tools are available. Toolsets equals DataTime toolset. Print T. Name for T in test model last model request parameters function tools. Now.
Calls the agent synchronously with a question about available tools, passing a DataTime toolset. The print statement outputs the names of function tools that were included in the last model request, showing only now was present. Tool registration in Pydantic AI splits cleanly into two worlds. Stateless utilities you pass to FunctionToolset via the constructor or add function, and stateful tools you register with at Toolset tool, where RunContext becomes the first parameter. The Weather Toolset shows both patterns side by side, plain functions up front, then a decorator-wrapped conditions function that reads CTX, run step to toggle output. The DataTime toolset goes the other direction entirely, starting empty and registering a lambda with a custom name. What ties it together is that none of this is baked into the agent. Each agent runsync call picks which toolset to expose through the toolset's argument, and you can verify exactly what the model saw by inspecting test model last model request parameters function tools. So the real decision point is whether a tool needs runtime context. If it does, use the decorator. If it doesn't, constructor or add function keeps things simpler.
The conditions tool brushes past the city, swapping sunshine for rain with every step it takes.